Hey, welcome to the shop. I'm Chris. You're watching Show Me Repair. Today we've got a 2018 Ford F350 with a 6.7 Powerstroke in. The concern is battery light is coming on the dash, but it's got dual alternator set up, and they've tried to do a little bit of diagnosis of trying to see which one's charging, but they're not getting anywhere. So let's check codes and go into diagnosis of this. One of the D's. Start diagnosing this and try to figure out what's wrong. I have a suspicion on what it is. I've seen this before on the 6.7 Powerstroke, and I bet we're gonna find something that's very common on these, and I just wanted to share it with you guys. Come on. There we are. Charging system service now. We got a PO625, generator field F terminal circuit low. Description for this code and conditions is generator field terminal circuit low, P0625. The PCM sets this DTC if the GenMon circuit is shorted to ground, the A sense circuit is open, or the B plus circuit is open. This DTC also sets by a faulted PCM or generator. So we could have a bad PCM, bad wiring, or a bad alternator. Ford likes to call them generators. I forgot why that is. Okay, let's go to, it does not specify which alternator. This being a dual alternator setup, so I'm going to have to test both, and we'll start with the driver's side first. And we do pinpoint test F. So let's start with F1. Perform inspection verification. Was an obvious cause for an observed or reported concern found? No, I've already done that. F2, check the generator connectors. Disconnect. Yeah, it's having to do both the alternators. Generator C102A and 102B. Inspect for corrosion, damaged push pins. Make sure they seat and latch correctly. So it wants us to check from C102B, and I'll show in the wiring diagram, that's actually the positive, the charging cable or whatever goes from the alternator to the battery junction box, and that goes through a 100 amp fuse to the battery. And this is the 102B. C102B is a connector for the primary generator on the driver's side. Hey, got the, I know you guys can't really see, but positive lead on the alternator stud, negative lead on the negative terminal of the battery, and we're reading good voltage, so we're good there. So is the voltage within half volt of the recorded battery voltage? Yes, yes it is. Was it about 12.2? It's reading 12.2 at the battery. F3, check the voltage drop in the generator B positive circuit. Start the engine with the engine running at idle. Headlamps on low or on high. Measure from C102B, so the same stud on the alternator, negative lead of the battery. So perform a wiggle test generator. Is the voltage drop less than half a volt? So basically it's wanting to really check that cable or the wire. Let me run that test and I'll get back with you. Okay, I checked for voltage drop. There was less than half a volt when doing that test, so we're good there. For DTC P0625, which is the one I'm going to go to F4. A sense circuit load test. The following step uses a test light to simulate normal circuit loads. Use only the test light recommended in special tools. Put the load on A sensor. If there are corroded or loose connections, loading the circuit may help show the fault. A 250 to 350 milliamp incandescent 12 volt lamp is required for this step. This circuit cannot be loaded correctly using LED style. Correct, yes, you do want to use an incandescent bulb. Ignition off, disconnect generator C102A. C102 is the actual wiring connector at the alternator, not the battery positive. Ignition on, measure and record. We got the connector disconnected. You can see the alternator sits right back in there. You can see the power cable on it. You can kind of see it down there. Pin 3 If we look over here, it's one all the way to the right. I've got my own little makeshift bulb here and pins. Okay, let's see what happens. I'd say that's good. Okay, so we passed the test on that step, but then also they want us to check for voltage at that pin and do a wiggle test. And I did that off camera. Everything was good. It wants to sense voltage within half a volt of the recording battery voltage. And that was good. So is the sensei voltage? Yes. Go to F5. Check the generator monitor circuit for a short of voltage. Ignition off. Disconnect the PCM connector. Ignition on. Perform a wiggle test on the generator wiring and measure from pin 1 to ground. So it's looking for, see if we have a short of voltage. Let me check that and I'll get right back to you. Okay, step 5, I did a wiggle test and checked for voltage on, and I had no voltage. So we'll move on to F6. Check the generator monitor circuit for a short to ground, and yes, it is greater than 10,000 ohms. It is not shorter to ground. So then we'll move to F7. Check the generator monitor circuit for an open. Let's check that. We will be testing from pin 14 of the PCM connector to pin 1 at the alternator. Okay, so I've got my pin. I don't know if you guys can see that very good. I've got my pin on the connector for the alternator on pin 1. 4 over from the left, so 4. 1.2 ohms. And I think it wanted less than 3 or less than 5. That's perfect. Let's move on to our next step. Yeah, F7 is the resistance less than 3 ohms. Yes, go to F8. Check the generator B+ internal resistance. So it's so focused. I've actually done a little bit digging on this already, and I already found an open wire. And it's actually on a circuit that, by the engineer standards, it should not have an issue, but let me show you. We're going to actually check resistance on the other circuit for the alternator, which is the control mod. Control, they call it a lot of different things. Anyway, it's pin 2. We see pin 2 right here. I've got it on pin 2 down here at the connector. And over at the PCM, it's pin 53. 3 in from the right. Where's my lead? Here it is. That's 53 there. If we look at our meter, we're out of limits. It is not reading, so we have an open on our yellow wire circuit CDC09, and it runs from the alternator to the PCM. There is a connector in between, but I'm not going to worry. I've already inspected that connector, and that connector is right over here. And I've already pulled that apart and reconnected it. We're good. I'm not going to say it needs a whole wiring harness. That's just crazy. Because really I need to make sure that I need to complete the circuit and make sure that's exactly what it is. Yeah, could we possibly get a wiring harness? But I don't know if anybody's priced a wiring harness for an engine from an OE lately. But an engine harness, because that's a part of the engine harness. For a bunch of the sensor connectors, they don't have, most manufacturers don't break it into separate wiring harnesses for, say, the injectors and then these sensors. They usually have one big wiring harness, and I would bet that that wiring harness is in the 1500 range, and by the time I pull it off of there, I could have probably 6 hours in it, including the time diag plus some. Hard to say what I run into, and then taking all that apart, you break things. So what I'm going to do is I'm going to snip my wire at the connector of the PCM. I'm going to run a whole new wire following the wiring harness all the way to my alternator connector, and we will then be able to prove, I mean, I'll basically I'm doing the repair and testing at the same time. We know we have an open, and a lot of people overthink this. Could I go digging in the wiring harness for the brake? Yes I could, but these wiring harnesses are very difficult to get to. Ford did a really cool thing on the 6.7, and you'll think, well, that's not a very cool thing because you're having wiring issues, but they ran the wiring harness in these plastic channels, and it works really good for keeping the wiring harness where it needs to be. The problem is they didn't account for debris that gets in there, and I've seen so many times rocks get in there and chafe stuff, and just you find all kinds of stuff in there. So what's most likely happening is the wires are chafing, their moisture gets in, it corrodes, there's an issue with the wire. I've seen this problem I don't know how many times, a lot. And the easiest thing to do, and I've had many customers, I go, well, we have two options. I can run a whole new wire, which will take me probably 20 minutes, or we get a new wiring harness. And they always pick running a new wire. So, I like to basically follow the original path. That way, if there was another issue, somebody can see that wire, follow, go to the pin on both connectors, know, oh, they overlaid that wire, good to go. So let me overlay a wire, and we will then check resistance just to do that again, and then we'll check to see if our code's still present. Okay, I've got my lead, positive lead from my voltmeter, ohm, whatever you want to call it, DVOM, what I was always taught, in pin 2. Ran my wire, you can't even see it, it's so good. And then I've got my negative lead in pin 53 here. You can see my wire run a little bit back there, and that's seriously how the original wire harness runs. It's weird. So then we go over to our meter, and we're reading extremely low ohms. It's under 1 ohm, so about half, which is perfect. Now let's go clear codes and see what we get. Okay, first thing we're gonna do, we get out of here, we're gonna go erase code. Codes have been erased, and then most likely we need to start the vehicle. See if it even comes on. Usually would have come on by now. Let's go read continuous memory. Oh, I got mass airflow disconnected. But we don't have a charging system code anymore. No fault codes, and we no longer have a battery light coming on. So right there is a perfect example of you can't always take everything that service information has as the exact truth. We had a code set for the charging system. The engineers designed testing to go down a path for something that wasn't even on that testing route, on the diagnostic. And thankfully, with experience, I know to just basically go to my charging circuit. Do I have power at my alternator? Yes. Do I see any problems? No. Okay, let's just check resistance from my alternator to my PCM. And I found off camera, before that I already knew that I had that broken wire, but I wanted to take you guys down the route and show you basically I hadn't even gone through the pinpoint test because I'm so used to seeing this problem, but I wanted to take you guys along and show you the process. That way, if you have a vehicle, you know the process to take. But then if we would have kept going down, there was several more steps to that pinpoint test, and I would have basically wasted time. It would not have taken me to the problem. So, but with experience, I knew that I need to just start testing everything generally with the system. So then that's where it led me to then test wires from the alternator to the PCM. I found the broken wire, and I was gonna do it, but I wanted to make a video and show you guys, and I'm glad I did, because that is a prime example of people with experience and somebody that sticks to the path and will not deviate because they go, this is what you have to do. Well, there's nothing wrong with that, but then you have to start questioning things when you get to the end of it and you have no answer, but you still have a problem. And you have to start kind of think outside the box and go, okay, what can I do? Could something else cause this? And it did. So I appreciate everybody watching the video and following along. I think there's some kind of new thing out where you can boost the video. I think it's called hyping. And within what I saw was like the first 7 days of a video that viewers can hype the video, and it helps video, and that would be awesome to boost my views. I'd really appreciate if you guys would do that. If you enjoyed this, actually don't just do it. If you enjoyed the video or you appreciate me sharing knowledge or something, well, or if you just want to, that'd be cool, but I would appreciate it if you did. If you don't want to, you don't have to. But I appreciate everybody watching. I'll see you in the next one. Thanks.